Welcome to Ask and Learn.
In this rod, we have a rod that's pinned at its lower end with a ball joint, and is resting against the other end is resting against the wall, and is also supported by a rope that is attached to it, then attached to another point along the wall. So in this problem, I'm going to use point A as my the first point. So at the ball joint, we have forces in all three directions, and that point is located using the origin that they give in the book as the origin for our problem, at a distance of 1.5 meters in the x direction. The force at the other end of the wall, or at the end of the rod, because the wall is said to be smooth, there are no friction forces, so we just have a force in the x direction that's normal to the wall. And we also have, at that point, we have the force in the rope, and it has a magnitude F2, and its direction is from point 2 to point 4, or in the book this is B to C. Point 2, where the end of the rod is, the upper end of the rod is in the YZ plane, and is 1 meter in the Y direction and 2 meters in the Z direction. There is weight acting on the rod at its center because it's uniform, and we can locate the position of the center by locating by going to position 1 and then going up a distance L over 2 in the direction from A to B, or 1 to 2. And then our fourth point here is where the rope is attached, and that is at a point 2.5 meters in the Z direction above the origin. So we can get these unit vectors now that we use to define our forces and positions by just taking knowing these points. So R24 is R4 minus R2, and then we can divide by its magnitude, and R12 is R2 minus R1, and we can divide by its magnitude. So we have all the information to calculate these unit vectors. And then once we do that, we have all of our force vectors and all of our position vectors, and we can sum forces and moments, and we get that so let's see here. We'll have five unknowns here. These three forces, this and this. We actually get 6 equations, but one of them is trivially satisfied, so we don't have to worry about that. So really, we only have 5 non-trivial equations out of these 6 that we get from force and moment balances. And when we solve for those 5 unknowns, using those 5 equations, we find that F1 is minus 58.9 in the x direction, newtons in the x direction, 39.2 newtons in the y direction, and 177 newtons in the z direction. The force against the wall is 58.9 newtons, so that's in the positive x direction, as we'd expect. And the force in the tension in the cable is 43.9 newtons, and again that goes from point 2 to 3 as we, or 2 to 4. So it's positive also, as you would expect.